Question number 40 says, evaluate integral 0 to 1 e power 2 minus 3x dx as a limit of a sum. Okay, limit of a sum. So remember the concepts of limit of a sum. What do we have? I equals integral from 0 to 1 e power 2 minus 3x dx. And we should remember that for limit of a sum, this expression a to b fx dx, remember this expansion, this is equal to what? This will be limit n tends to infinity b minus a upon n. In the bracket you have f of a plus f of a plus h. In those rectangles you are taking the left hand side aside. F of a plus n minus 1 h. The important thing is h is equal to b minus a upon n. Find the values of a, note the values of a. A is equal to 0 by comparison. B is equal to 1. H is b minus a upon n. B minus a upon n, which simplifies to 1 minus 0 upon n. This is h. What is f of x? F of x is this function e power 2 minus 3x. This is what you have. Okay, and now we can substitute these values over here to give you, therefore, integral from 0 to 1 e power 2 minus 3x dx will be equal to limit n tends to infinity b minus a upon n, which is 1 upon n. In the brackets you have f of a, which is f of 0, plus f of h plus f of n minus h. So f of 0 will be e power 2 plus e power 2 minus 3h plus e power 2 minus a plus 2h will make it 6h plus dot 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 plus e power 2 minus n minus 1h is what you'll have. If you observe, you are dividing with e power 3h, dividing with e power 3h, dividing with e power 3h continuously. So this is a geometric progression. The sum of geometric progression is not difficult for us to find. Therefore, I is equal to limit n tends to infinity over here. 1 by n is okay. For this geometric progression having total 0 to n minus 1 n terms, first term is e square. The common ratio is e power minus 3h raised to power number of terms minus 1 upon common ratio minus 1. This into this is the sum of that, and after this we'll put the limits, right? So we'll need some concepts of limits along with that. Over here this is limit n tends to infinity. 1 by n is okay. Substitute that h is equal to 1 by n. Use that value over here. E square is also okay. This in the bracket becomes e power minus 3 nh. So nh is 1. This is e power minus 3 minus 1 upon minus 3h minus 1 is what I get. Right? H can be simplified, or this 1 by n can be written as h. Oh, as n tends to infinity, you can say limit h tends to 0. This 1 by n is actually h. E square e power minus 3 minus 1 is okay. This 1 by n is h upon e power minus 3h minus 1. So e power something tending to 0 minus 1 upon that very same thing will be 1. If that is the case, then you need to multiply with minus 3, divide with minus 3. That is extra manipulation which is required. Once you do that, this is e square e power minus 3 minus 1 upon minus 3, and this overall limit e power something minus 1 upon that something which is tending to 1. Yes, this is what you'll get. This is what you'll get. What is this equal to? This is minus 1 by 3, or you can take out that 1 minus inside. This is e square 1 minus 1 upon e power 3. That's your correct answer for this question over here. Is that all? Yes, that's all in this 40th question.